Whisker and stem and leaf plots. Both of these plots are used to represent a set of data. You might remember sets of data where we found mean, median, mode, and range. We're still talking about sets of data, but now we're talking about different ways to represent them. A box and whisker plot shows the smallest and largest numbers. It shows the median, and it shows the quartiles of a set of data. And stem and leaf plots order the numbers in a set of data. We've talked a little bit about stem and leaf plots already, but box and whisker plots are probably new. A quartile is going to cut a set of numbers into 4 different parts. Notice this is a box and whisker plot. We do have the box in the middle, and then the 2 lines that are going from left to out from the box are the whiskers. This would be the first quartile starting from left to right. Then we would have the second quartile. Notice it's the box, the left side of the box that's cut by this line in between in the middle of the box. And then we have the third quartile and the fourth quartile. The line that cuts in the middle of the box is going to be the median of the set of numbers. In this case, notice the box and whisker plot is over a number line, so I can know that the median is 49. The number furthest to the left is the smallest number in the set of data. In this case, it's 35. And the set over here is the largest number. In this case, it is 57. To create a stem and leaf plot, it says what are the minimum, first quartile, median, third quartile, and maximum of the data set below. Just like if we were trying to find the median, we have to order the set of data from least to greatest first. So we're given 27, 12, 20, 15, 40, 33, 19, and 26. I'm going to go ahead and order those from least to greatest. If you notice, we have an even number of data in this set. We have 8 numbers in the set of data. Notice on the orange lines are separating it into halves. To find the median first, to find the median, we would need to add 20 plus 26 and divide by 3, which gives me a median of 46 divided by 2 gives me a median of 23. Notice the minimum number is going to be 12. The maximum number is going to be 40. Now, because a number from the set was not used for the median, we're going to keep all of the numbers to find the quartiles. Basically, what we're going to do to find the quartiles is we're going to find the median of this set 12, 15, 19, and 20. So the median on the left side of the median of the whole set, and then the median of the numbers that are on the right side of the median in the whole set of numbers. So notice we have 12, 15, 19, and 20. When you're finding the median of these 2 numbers, you're going to have to add 15 plus 19, which gives you 34. Divide by 2, which gives you quartile 1 is going to end at 17. Do the same thing to find quartile 4. In the median, we're going to have to add 27 plus 33, which gives you 60. Divided by 2 would give you 30. That's going to be the end of quartile 3, beginning quartile 4. If we were going to make a box and whisker plot, we have to have the number line. Notice I've labeled my minimum, my quartile 1, my median, my quartile 3, and my maximum. We have a whisker from 12 to 17. Then that's beginning quartile 2, so we have to have a box. Notice my median, 23, is a line through the box. 30 is the end of quartile 3, the beginning of quartile 4, and then the maximum is 40. So I've created a box and whisker plot. based on this set of data. The next one tells us that we have runners and then their time in seconds. Again, I'm asking you to write create a box and whisker plot. Always start by ordering the numbers from least to greatest. Now in this case, I have an odd number of sets. I have an odd number of data in my set. When you have an odd number, that means that the median of this set is going to be this 34. Because that is actually a number from my set, I am not going to use that to find my quartiles. So 34 is the median, but now I'm not going to use that anymore to find the beginning and ends of my quartiles. So I'm looking at the numbers 30, 32, 33, and 34. To find the median or the quartiles of these, I need to add 32 plus 33 and then divide by 2, which gives me quartile 1 is going to end at 32.5. Do the same thing to find the end of quartile 3. We have 36 plus 38 divided by 2 gives you an end point of 37. I'm going to use this information to create a box and whisker plot. I need a number line with my minimum, 30, my quartile 1, 32.5, my median, 34. We have an end point for quartile 3 at 37, and then a maximum at 40. I'm going to make my box and whisker plot by having a whisker from my minimum to the end of quartile 1, which is 32.5. Then I'm going to have my box from 32.5 to 37 with my line at the median, which was at 34. And then we're going to have another whisker going from 37 to the maximum, which was 40. This is a stem and leaf plot. A stem and leaf plot, generally speaking, sometimes it'll tell you that this is representing hundreds, so you would have like 190. But in this case, when it doesn't say anything, and sometimes you'll also be given a key, but when it doesn't say anything, we're going to assume that the stem is going to be the tens place, and the leaves are going to be the ones place. So this would be like having 19 and 19, where the stem is 1 and the leaves are 9. You would have two 19s represented in that row. If you look at the stem of 2, that would be representing 21 and 25. The leaves are the ones place, the stem is the tens place, and so on. The first question asks us, what is the smallest number represented in the data set? Notice these are ordered from least to greatest if you're starting at the top and working your way down. The smallest number represented in the data set would be 19. Then it asks us what's the largest number represented in the data set. If you look at the very, very bottom, the last number represented, it is 62. Then it asks us how many numbers are greater than 40. When we are looking at numbers greater than 40, that means we need a stem of 4 or greater. Notice one of the numbers is 40, so that's not going to be greater, so that one doesn't count. But then we have 42, 49, 55, 61, and 65. So there are a total of 5 numbers that are greater than 40.